Good morning, everyone. Today we are going to have a class on aseptic area. Aseptic area. So, what are the learning objectives of today's class? I'll be having a discussion on introduction, what are the aseptic techniques, what is the designing of an aseptic area, surfacing material, and services. Let us start with the introduction. Aseptic areas are employed to provide protection to ophthalmic and parental products by preventing the entry of microbial and particulate contamination. Prevention of microbial contamination is also required to remove pyrogens and toxic bacterial products. The terminally sterilized products sealed in a container and then sterilized, are prepared in clean areas, while products not terminally sterilized are prepared under aseptic condition using sterile materials and are sterilized by filtration before being packed into a sterile container. Such aseptic processed products are formulated or prepared in an aseptic area, which is a room within a clean area designed, constructed, serviced, and used for controlling and prevention of microbial contamination of the product. Like sterile medicinal products, vaccines contain dead microorganisms, microbial extracts, or inactivated viruses are also filled in aseptic areas, while live or attenuated vaccines are filled in separate areas. The goal of any facility is to design such an aseptic or a sterile environment which provides a controlled environment so that the entrance of viable, microbial, or non viable particles, dust, contamination may be minimized. A controlled environment prevents cross contamination of compounded sterile preparations. We call it as CSPS, compounded sterile preparations. To reduce the contamination related risk, all compounding should be done with primary engineering control like a laminar airflow hood. So all things should be conducted in a laminar airflow hood. Now, how is the designing of an aseptic area? This is exactly the design. If you see, the room should be as such. First, there will be an office where you have to come. It's called as an air block office, and then there will be a area where doors will be there. Door will always have a negative pressure so that the air from outside will not enter as you enter inside. Air from inside should come outside. Now, designing of aseptic area, the sterile production area, it can be within the hospital or factory, should be located separately. Sterile unit of production should be buffered. Unauthorized person should not gain access to the entry. Now, let us see the design. After the area of the office, we have a preparation room, compounding area. Exactly after the compounding area, we have an aseptic filling area where we can do filling of ampules, injections, and then a quarantine area. Quarantine areas are kept so that if there is any growth or any contamination, it can be seen and the product can be later. We can minimize the errors. Then storage will be there. At the same time, the office will have a connection to the storeroom as shown in the diagram. Then there will be a cleanup area in the preparation where we prepare. We have to clean the area, so cleanup area is separate. Then sterilization area, because all equipments whatever we have used in the process, glasswares, metals, it has to be sterilized. In quarantine area, the next area what comes adjacent to that is called as a packaging and filling, and then it goes to the storage and shipment, and then it goes to the quality control check. So this is exactly how an aseptic area should look like. The references is taken by N.K. Jain, Book of Pharmaceuticals, second edition, Vallabh Prakashan. Aseptic area is designed to carry out each stage of production separately. The unit should also ensure a safe and organized work before, so that we need for personnel to move around and cleaning room is minimized. The unit is built and the equipment is positioned in such a manner that the product remains protected from contamination. The layout of specific area should be such that the cleaning can be done easily, dust accumulation can be reduced, arrangement should be as such that the risk of cross contamination of one product or material with another is reduced. The filling area should be adjacent to the compounding area where the personnel assemble and prepare materials utilized by the staff in the filling area. Design and construction. Only authorized personnel can gain access to the clean and aseptic filling area. Personal entry A personal entry, the clean rooms, person entering the clean room by passing through the changing rooms where they put on and remove their clean room uniform. So, uniform is separately designed and given to them, which is sterilized. A passover, a bench across the changing room for a physical barrier of different areas for changing by the personnel. Special precautions are taken to prevent cleaning an aseptic filling area for getting contaminated, while materials are being passed through the airlocks or hatchways. Thus, sterilizers and entry ports are fitted with double-sided doors which are interlocked to prevent stimulation opening of both the doors. Surface material, the floor, wall, ceiling of the clean room should be smooth, impervious and unbroken to reduce the release and accumulation of contaminated particles and organisms. The surface material should be such that they have to withstand the effect of cleaning agents and disinfectant. The ceilings are scaled so that contamination do not enter from the space above them. Uncleanable recesses should be avoided with the clean rooms to minimize the accumulation of contaminating particle. Thus, the wall floor junction should be covered. Minimum shelf, ledges, cupboards, equipment should be present. Non-opening sealed windows present to prevent the entry of contamination. What are the surfacing materials? These are the surfacing materials what have been used. Now we'll look at what are the services we are giving. The pipetted liquids and gases entering the clean room should be filtered first, ensuring that the liquid or the glass or the gas at the work position is clean and the air is in the clean form. The position of pipes, ducts should be such that they can be easily cleaned. Other fittings like fuse boxes and switch panels should be outside the clean room. Sinks and drains should be present in areas where aseptic procedures are carried out. Within the clean room areas, there should nowhere be present in the complete unit. The areas having sinks and drains should be designed, positioned, and maintained such that the risk of contamination, microbial contamination, is reduced. Therefore, easily cleanable traps installed with electrical heated disinfectant devices. Limited number of doors and ports should be present for the entry of person and material, especially the entry doors should be self-closing to allow easy movement of personnel. Airlock doors, wall ports, through the wall autoclaves and dry heat sterilization should have interlocked doors to prevent stimulation opening of both the doors. All the doors should have an alarm system which should ring when more than one doors are being opened. Light in clean room should be fitted with the ceiling so that dust accumulation reduces and also the airflow pattern within the room is not disturbed. Equipment in clean room should be positioned such that the accumulation of particle and microbial contamination does not occur. These are the references. The book is N.K. Jain, Pharmaceutical Microbiology, Vallabh Prakashan, and one more is of Pharmaceutical Microbiology, first edition by Manivam R. Singh and Patel. So that's all for now. Thank you. Have a nice day.